For a recent problem, Cal Q was lower, took the equation f of x and found f prime of 2. How could the problem have been worded for Cal to know to do this? Okay, so if I am taking the derivative, another way to say that would be find the rate of change of f at 2. That's one way to say it. What's another way? I'm going to find what about the tangent line? The slope of the tangent line. So find the slope of the tangent line. X is equal to 2. Okay, so a linear approximation. To find the linearization at x is equal to c is to find a line that best models the data at that point. So all we're doing for a linearization is writing the equation of a line. That's it. And we need to know two things to write the equation of a line. We need to know a slope, and we need to know a point. That's it. So to do this, we are going to write the equation of the tangent line. So let's look at an example. It says find the linearization of y is equal to x cubed minus 2x squared minus 5x plus 1 at x is equal to 2. So I'm going to get my point. X is 2. How do I get y? Right here, I have a little equation for it. So I'm going to take the x value and plug it in to get y. So I plug in 2. That's going to give me 8 minus 8 minus 10 plus 1, which is negative 9. So I have my points. The point I'm evaluating it at is 2 comma negative 9. And so now I need the slope. So I'm going to take the derivative. And so the derivative in this case would be 3x squared minus 4x minus 5. And so now I'm going to evaluate the derivative at x is equal to 2. Okay, so I want y prime at 2. This notation just means that I am evaluating the derivative at 2. So I'm going to take 2 and plug it into my equation. So let's see, that's going to give me 12 minus 8 minus 5, which is 12 minus 13. So my derivative evaluated at 2 is going to be negative 1. So I have my slope, I have my point. So now I'm going to write the linearization, which is just, you can either write it in point slope form or you can write it in y-intercept form. So I'm going to write it in point slope form to start. So I've got y minus my y value, which is negative 9. So that will be plus 9. And that's equal to negative 1 times x. And then I need to plug in my x value, which is 2. So minus 2. So I could leave it like that in point slope form for my linearization, or I could write it in slope intercept form. So that's y equals mx plus b. So I'm going to distribute my negative 1. So my slope would be negative 1. And negative 1 times negative 2 gives me positive 2. And when I move the 9 over, that's going to give me 2 minus 9, which is negative 7. So either one of these two equations here would be the linearization. Okay, so That's fairly straightforward. But are there any questions over anything that I did there? Well, I don't know if you know this. I haven't told you, but you may know this, but in case you haven't, let me introduce you to your new best calculus friend. Math 8. Your calculator will calculate a derivative at a point. Do we know this, or is this new? Well, let's check it out. Math 8, my new best calculus friend. At least until you meet Math 9, right? But we'll get that. So take your calculator, and I am going to share my screen here with the calculator. So you need to go to Math 8. So I'm going to click on Math. Notice option number 8 is in deriv, which means that your calculator will calculate the derivative at a point. So I'm going to select 8, and it comes up into this notation, at least if you're using one of the newer calculators, right? And so this notation, I need to put an x in here. This d over dx means I'm taking the derivative with respect to x. Inside the parentheses, I need my equation. So we're going to find the derivative of what we just did using the equation that we just did. So inside the parentheses here, I'm going to put in my original equation, which was x cubed. Let's see, x cubed minus 2x squared. And then minus 5x. And then we got a plus 1. Okay, so I'm going to take the derivative with respect to x. My equation goes here inside the parentheses. And here, this is where the point at which I'm evaluating it at, which in this case is 2. And then I hit enter. And bam. Look at that. My calculator is not quite as smart as you find people, right? Because when we took the derivative, we got -1. And so the calculator is using approximations here, but it's very, very close. Okay, so -0.99999, which is -1. So from now on, if you have permission to use your calculator, please use it. You're like, okay, coach, got it. You don't have to tell me twice. You say that now, but like 2 months from now, when we're doing a mock exam and there's a question, and you spend like 6 or 7 minutes trying to work the multiple choice problem when you could do it in like 15 seconds using your calculator, I'm going to say, use your calculator. Math 8. Okay, got it?
Coach.
I will show you how to do that. Okay, so if you have a TI-83, you need to put the equation in. So you would put this equation in just like that, then put a comma. Comma is just above 7. Then put x, because it is with respect to x, and then put another comma, and then put the number you are evaluating it at. So in this case, it would be this equation, comma, x, comma, 2, close your parentheses.
Okay.
Okay, so let me know if you have an issue, and I'll help. All right, well, let's go back to our notes here for just a second. And let me just make sure that we have the notation, okay? We need a d over dx, the equation goes in there, and then x is evaluated, so I have my x value there, okay? So that's the notation. And let's look at example 2. It says, find the linearization for y is equal to 4 raised to the x minus 3 at x is equal to 1. Okay, so just for a little review, let's review how to take this derivative by hand. First of all, what's the derivative of 4 raised to the x minus 3? 3. Do we remember this? I hope so. It would be okay, so we bring this down. Now what?
Times 1.
Y times 1
Is the derivative.
is the derivative of the exponent times what? The natural log of the base, which is 4. Okay, so now take your calculator and calculate the derivative of the function at x is equal to 1. And let's get a decimal equation there. Go ahead and do that for me right now. So you're going to do math 8, and your equation would be the original equation here, 4 raised to the x minus 3. Then you evaluate that at 1, and somebody help me out. Tell me what you got. The derivative at the point is I got 0.0866. Okay, and so they asked me to find the linearization. I have the slope. I need my point. Okay, so it's evaluated at 1. And I'm going to take 1 and plug it into the original equation, which is going to give me 4 raised to the negative 2. And so I could write that as 1 comma 1 over 16. The negative exponent, I can move to the bottom and make it positive. And so that would give me 1 over 4 squared, which is 1 over 16. So now let me write the linearization. I have my slope. I have my point. I'm going to write it in point slope form. So let's see. It's going to give me y minus my y value, 1 over 16, equals 0.0866 times x minus 1. Yes. I don't know. I can check it in just a second, right? But that's right. Okay. Questions on that one? Linearization. We're just writing the equation of the line, and if it's a calculator problem, use your calculator to find the slope. Okay. Example 3. Information about the difficulty of the calculus test is spreading in a way that can be modeled by this equation. N is equal to 485 over 1 plus 3 raised to the 4 minus c, where N is the number of students who have heard about the test, and T is the number of hours after first period completed the test. So the question is, how fast is the information spreading 2 hours after first period? Answer with appropriate units. Okay, so what are they asking me to find? Is it an amount or is it a rate? It is a rate because it says how fast is the information spreading. So if it's a rate, this would be like my position function. And so since this is a rate, I'm finding the derivative of this, which would be like a velocity. So I want to find n prime of 2. So take your little calculator, do a little math 8, plug in the equation. And somebody help me out here with what you got with n prime of 2. Anybody? 47 points. 954. And let's put the units on there. This is a rate. The amount is measured in students. The time is measured in hours. Okay, and so we would probably round up to 48 students per hour since we are talking about people. Okay, so I have one more example now. Example 4. Example 4 says the position of a particle can be modeled by S of t is equal to e to the 2x sine of x squared minus the natural log of x plus 3, measured in feet. Part A, find the position of the car at t is equal to 2 hours by looking at the table of values. Part B, find the velocity of the car at t is equal to 2 hours. So whenever you get a calculator problem, either for me or on the AP exam, the very first thing that you do is to put the equation into your calculator. Triple check it to make sure that it's right, but put it into your calculator. Okay, so do that for me right now. I am going to go to my calculator here and go to y equals. And so I put in e raised to the 2x sine of x squared minus the natural log of x plus 3. And we are in radians always in calculus. I'm going to check and make sure that it is right. And so part A says find the position of the car at t is equal to 2. So this equation that I have in my calculator here is the position function. And so I just need to evaluate it at 2. So once I get my equation into my calculator, I'm going to go to the table of values. So let's hit second graph there to get the table, go down to 2, and I get negative 42.93. Duh. Everybody with me? Okay. Part B says find the velocity of the car at t is equal to 2 hours using y bars instead of retyping the equation. Okay, so what I mean by that is that you only put the equation into your calculator once, and then you let the calculator work its magic. Okay, so if I'm finding the velocity, that is the derivative of the position function. So I'm going to use my good new best friend math 8. Right? So here we go. Let me get out of here. I'm going to go to math 8. It's with respect to x. And here's what I mean. I'm not going to retype all that. It's already in my calculator. So go to alpha trace F4. There it is right there, Y1. I hit enter. And so what that does is it takes the equation that's stored in my Y1, in my calculator at Y1, and puts it automatically in there. And then this is evaluated at t is equal to 2. So this will give me the velocity of the equation at 2. I hit enter and boom, negative 225.590. On yours, okay, go to variables, y variables, function, y1, I believe.
Where's y variable?
It should be hit variables and then scroll over.
Oh, okay.
Got it?
How did you get the y1?
Okay, let me go back and do that. Okay, so I'm going to go to math 8. And there's a couple of different ways to get there. It's in variables here, but the shortcut, if I hit alpha trace, that's going to pull up F4 here, and these are the shortcuts for F4. And there's Y1, Y2, Y3, Y4, all of those. And so Y1 is highlighted. I'm going to hit enter. So alpha trace enter will give you the Y1. And then I'll plug in 2 and I get that. So let me go back and write those down. Okay, so find the position of the car, looking at the table of values, this was negative 42.93. And then when I took the derivative using my calculator, this gave me negative 225.590.